Hello and welcome to lesson 2.4, Rational Equations and Inequalities. So today we're going to review some of our skills with rational equations and inequalities and how to solve them. So here we're going to solve this equation. This is a rational equation. First, what we're going to do is we're going to find the lowest common denominator between the two. So that requires me to multiply the left side by x plus 5, both in the numerator and in the denominator. And on the right hand side, I'm going to have to multiply by x plus 3, both in the numerator and denominator. Now, as you learned in grade 11 and grade 10, you shouldn't actually expand the denominator, you should only expand the numerator. Now, because this is an equation, you can actually drop the denominators and just work with the numerators and find out when they're equal to each other. You could, in essence, keep the denominators and not actually change anything, but it's not necessary to actually keep them. Once you drop them, you do have to state that x can't equal -3 or -5 as a possible solution. So now you have two quadratics equaling each other. Expand and simplify. Gather like terms. And solve. Here you see a solution does turn out to be x equal to -1. If the value did turn out to be -3 or -5, please realize that was not possible due to our original restrictions. And that's how you solve a rational equation. Find the common denominator. You can drop the denominators if you like, and solve for when this function is equal to 0. So let's take a look at another situation. So the other situation is dealing with rational inequalities. It has a similar overtone, but it deals similar to what polynomial inequalities deal with. So again, first find your lowest common denominator. So in this case, multiply both sides by x minus 1. On the left-hand side, both the numerator and denominator. And we're going to multiply the left-hand side by x minus 2. Right-hand side, both in the numerator and denominator. Now, unfortunately, in this case, you cannot actually get rid of your denominators. You have to include them. You got to keep those factors there to verify where your function is positive or negative. So at this moment in time, I'd move everything to one side. Doesn't matter which side you choose. And make it all one fraction. Now, at this moment in time, what we're going to do is we're going to expand and simplify the numerators, if possible, and see what we get. Okay, so what I have here is 0 is less than just x minus 5 over x minus 1 times x minus 2. So here we have an expression that we're interested in solving. We're trying to find when this fraction, x minus 5 over x minus 1 divided by x minus 2, is greater than 0, or when is it positive. So what we can do again is something that we did from our last problem, last polynomial inequalities, is deal with creating an interval chart. Now here, x cannot equal 1, x cannot equal 2. These are restrictions. So this will help us break up our expression. Also, realize we're not interested in when x equals 5. This is a 0 of the function. We're only interested in where it's positive or negative. So again, we should use 5 as another spot where we can break up our function. So we're going to create our interval chart. We're going to look at x values less than 1, between 1 and 2, between 2 and 5, and x values greater than 5. The intervals we're going to use is the factors we're going to use are x minus 5, x minus 1, and x minus 2 to get our result. So again, it's just like the interval chart we created with polynomial inequalities. So I'll give you some time to fill this out. Pause the video at this moment, fill this out, check your answer at the end. So this should be your result. So this means the function is greater than 0. So x minus 5 over x minus 1 over x divided by x minus 2 is greater than 0 on the intervals when x is between 1 and 2 or when x is greater than 5. And this is how we'd go about solving it. Now, if you were interested in when this function was less than or equal to, we'd be just changing one of these results, and that would be the result of x being greater than or equal to 5. Remember, x can't equal 1 or 2, so that's one that we cannot include, but we'd have to include x greater than or equal to 5 if the original equation had a less than or equal to sign. And thus concludes this lesson.